start. It's basically the same presentation from last time, but I have made some changes, add some stuff, but, just the finishing touch. I try to start from the bottom and finish it after everything I have done so far, and everything we have on the project so far. Might have missed a couple of things, and we'll talk about it if we realize that.
Have you already started, or
Yeah, already.
does he need proper introduction?
Oh,
Don't speak loud.
oh, okay.
Maybe,
You
okay.
don't care. Okay. Okay. Let's start this again. My name is Ravindra, and I'm an undergraduate student of computer science, and this is Rnassac project funded by Rnassac, and Dr. Aslan is the owner of the project, and we started this project back in 2014 October. 15 October, thank you. And since then we've been trying to work this thing out, and so far we've got a website and an application and search functionality. So I'm going to talk about our achievements so far, and I'll try to explain how we have designed and implemented our programs here today. Okay, let's get started. So first idea was to have a program that can do a efficient RNA substructure search and comparisons. And to implement the idea, we created a web application. And in the design phase, we had to decide what to do with it, right? So we obviously went with the Java J2EE application, as I told you earlier too. And this is Java Enterprise Edition, and it is basically designed for a high-scale application. But since in the future the application might expand and has much more functionality, I think this would be the great idea to start with. I actually added some details here, which wasn't present in the last slide, I guess. So this is what basically the structure of J2EE look like. Okay, but we don't have the database part. Instead, we are using files to read the data from. But we have the web container, we have the servlet, we have JSP page, and instead of enterprise bin, we are using Java bins. And we have application containers and client machine and as browsers, all these things. So it basically handles all the requests coming to the servers. It solves the JSP page in return to the client, and servlet communicates with the other class like Java Bean in their own time, which makes the application very lightweight. Okay, let's move to another one. Okay, here also I added some lines so that it is clear what these things represent in the project structure. So we have the package container and controller class, and I have defined some of the classes too, what classes are doing, like the read CSV. It is reading the RNA file, name, structure, and nucleotide from the CSV file. Similarly, okay. Like here you can see this is Maven dependencies. That includes all the API that is required in the project. But we use Maven to add those API instead of adding it to the reference library manually. It's a lot more easier. And then we have a web app folder. That is the client side. That is what is served to the client by the application. And our Verna applet is also sitting here on the resource. And down below we have form.xml file, which we'll discuss later. Here. Okay. The Maven is nothing but build tool. So it is just building our application in a way of structure that is required by the standard protocols of web applications. What is the hierarchy of the folders, where the files should be, and how they communicate. It already knows all these things, and it does those things for us so that it's easier for us to work on. We can focus on the design part than the structure. So this is how we add the dependencies and APIs. using a dependency tag inside the form.xml class. You can see here some of the APIs that we have used in our project. This diagram explains most of the operations of Maven build tool. It validates the code, it compiles, it tests. We can use it to test. It will create a package. We can use it for integration testing, verifying, installation, deployment, all these purposes. Like right now, our deployment is not automated, but we can install Maven in our server and make it a automatic deployment and automatic updating and all that thing. But it takes so much time that we didn't get to do it. But we have this tool in our Eclipse and work environment, so we're still using it for building purposes.
So it's not on the server, but it's on the laptops, right?
In the server, we are already using the final product on the server, because server is like our test environment, not the development environment. The Eclipse, we are using Eclipse for our development purposes, right? So another very important aspect of our project was Spring MVC framework, the design pattern of our web application. So we have basically model view controller, and that's how we handle all the requests and responses coming and going to the applications. So it is all handled by a dispatcher sublet, and the controller class, we annotate the classes and the methods. The Spring annotation makes it so much easier to define those classes, and then it makes it available whenever it's required by the application. So in the picture it will be more clear. So we have incoming requests, and the request will be first handled by the controller, front controller, or let's say controller, and then once the controller processes the request and it has the output, it will return the model and the view phase, and that will be returned to the client by the front controller. This is the structure of the servlet engine, and I would like to show you some of the codes here, like this one. You have seen this before too, but now I have added some lines so that it is much more clear, even in the future if you want to go through this again. So the annotations here are the most important part in this class, because this annotation is defining what that class is responsible for, and this comes from the Spring framework that we are using, and it is included using Maven. So this automatically recognizes that this class is the sublet class, dispatcher sublet class. Okay, so and we are calling some functions here and defining some variables, and it will return a page. All kind of operation is done here. So more on this on the next slide. Okay, here is the request mapping and request param, model attributes. So if you notice all these annotations, that is what is actually the driving force of this class. That is what it makes it a sublet class. So by mapping the request, we are handling the request coming to the application, and it will match the value and check which page to return, and then it can also pass a variable back and forth from page to sublet, sublet to page. You can either pass a single variable with the request param or class. Like in this one, we are uploading a file, so we're using a multi-part file as a request param. So when the user uploads a file, it is the sublet stores the file into its own local location. Okay? So if something goes wrong, obviously we have try, catch, exceptions. So this is a very nice example of how to handle a request. Let's move on to the view. This is what is the home page that is served to the client. Obviously we have done some modifications here. It might look a bit different now, but mostly the things are same. Okay, so JSP, everything else is HTML. I know you guys are familiar with HTML and tag libraries, but the JSP is a little bit different than a regular web page or HTML or CSS because it comes with a JSP tag libraries that provides it with extra functionalities like if you want to perform some computation on your client side, you can use some tag libraries and they are designed for specific purposes. And you can even design your own custom tag libraries. But we haven't used any custom, but we did use one of the libraries from code and we used it to manipulate our loop inside our JSP page. I think it's in the Barno class or somewhere like that. Okay. And obviously you can save cookies and stuff using session, but we didn't really have to do it yet. So in the future, if it's required, you can do that from here too. Okay, the next phase was to choose what engine to use to run our web application. Like there are so many available, like open source these days, but Apache is the one that is very famous. Right? There is Glassfish servers and other servers too, but I chose to go with the common one. And Apache is very, it's very popular, so that it has well documented, and you can go through the documentation and read, and you can do some new stuff. It's not very hard, but you have to go through documentations. They have everything documented very well, how to deploy, how to run an application on their engine. So it's basically, it's the container, servlet container implements we had to upgrade to a different version, I guess. Yes, we had to use Tomcat. No, we upgraded Apache. We didn't upgrade Tomcat. It's just a simple server, web application server. It is just, but it can do operation by itself to solve a page, but that is not very recommended because you don't want to get into security issues. So we did add a layer after this. We added an Apache web server. I'm going to get to it in a second. But this is very powerful engine, and you can run multiple instances of this, and you can scale your application as per your need in the future. Like right now, we're just running one instance because we don't really expect a heavy load of users in our applications. But in the future, if you need to expand, then you can run multiple instances. In multiple instances, you can run multiple applications, and handling those applications will be a lot easier afterwards.
Just to understand better,
Yes.
I was discussing this with a
Yes.
student earlier.
Yes.
Ultimately, at the end, on the server, a copy of the application is always running, right?
Yes.
Is it correct?
Yes.
Because arrays, all these things are created once.
Yes.
Certain objects, one instance of an object, for example, is created
Yes.
once.
When this application, this engine starts, it will be here. This part, because when this class is initialized here, before running into any method, we are already doing these operations here. That is when we store stuff in our memory, which will be available immediately, and that makes the computation faster.
But when multiple users, multiple clients exist,
Oh,
how
okay.
do they share a single object? Is Tomcat, for
No,
example, handling
Actually,
that?
we are okay. So I am here, sitting here. So somebody makes a request to me.
Right.
So I give them one copy of the application. If you make a request, I give one copy of the application. So I am distributing the copy. So it's all independent. But if you make any changes, then changes will be on me. So the other one gets a new one. So that's how it works. Like if they added some new RNA to our database, then the new customer who is accessing our database will have that new RNA available for him. But everything that we send to him is independent to each other.
If you create one large object,
Yes.
so at the end that object is shared, right?
Yes.
It's not there are no
No.
multiple copies
In the
of
server,
this.
it's always one instance.
One instance. It's the context. It's
But
the
we
context
can definitely
that
run
is-
multiple instances. That's what I was saying on the Tomcat. Like right now we are just running one instance, right? But if the load, sorry, I might have crossed somewhere. There. Okay. So if we have to serve too many customers and the same object cannot handle too many requests, like eventually it will reach its limit and then we'll have to upgrade. So in that case we can run two instances, but maybe we have to upgrade our hardware to support this software too. So
But we are not there yet.
yeah, we're not there yet right now. Right now we are trying to run a single application.
Right.
Okay, so I'll come to this again in the infrastructure side. Okay, so basically we have a home page, and in the home page, basically we have a database of RNA, and we convert those RNA structure to our representation, and we create a suffix array, and we load the suffix array into the memory when the application starts, and also we load the array name, nucleotide, and representations, all this into the memory in the beginning of the application, so that these will be available in the runtime. So, sorry, why am I going back? Okay. Oh yeah. Okay, I was trying to show you this because this explains what was happening over there. We're doing everything in the beginning of the application. Okay, so in the search part, now next important one is the search. That's what we have accomplished so far. For search, we ask the user to upload a file, and then it has to be a certain format right now, like maybe Rnassac, right? So once we get that file, we convert that file to our format, and then we process it, and then we perform the search against our suffix array, and then we collect the results. And here is the example of one of the results. Maybe it will come in like it will return us the indexes of those RNA and the indexes of the matching structure, and then we use those indexes to find the RNA in the array, and then we pass it to where we upload. Right now you can upload the same file and do two different searches. This is the suffix search, it will load RNA, and this is just the text search, which is based on Fatma's thesis project. Now it's the Varna. So we found this great application, and then it is very lightweight. That's why we are able to send it to a client and run it there in their machine in browser. But it doesn't support Chrome because JNPL plugin is disabled in Chrome. So it has to be either Safari or Mozilla Firefox to run this application, or Internet Explorer, I think it supports too. And basically when we collect the results earlier, and then I think we store it in an array, and then we pass it to the Varna application, and then from there Varna takes care of how to display it. So here also I added some of the lines. So in this tag, this is the applet tag, and this is where I'm defining the UI for our graphics part of the RNA, how we display our RNA structure in the page. So this applet, we have defined the path here in the archive where the file is located at. I mean, the code base is the path, and this is the file name, obviously. And we define the height and width and the alignment, so where to display how big size. So maybe in multiple view later in comparison we might have to change the height and width so it fits in the screen. And then there are various parameters. It's a very I couldn't find the word. It's very dynamic. You can change it in very different way, many different ways. It can take many different shapes according to the parameters you pass it to. So here I'm passing it the nucleotide from the array that is sent by the sublet to this page. Similarly the results, but this is just the initial value. So this is just like initializing the structure so that it won't come out blank in the beginning. This will just give one of the results, like it will select one random or maybe the first one. And then similarly the title gives the RNA name. See, I'm using 7, 7 and 6. Okay. Because this is two different arrays.
Ravi, are
Yes.
these your variables, nucleotide array,
Yes.
6, default
These
results?
are the variables,
This is a two-dimensional array, right?
Yes. You can actually.
Did you define them somewhere? Did
Yes.
you explain what they are?
Actually, this is defined in the servlet. When I pass the model attribute, like I have to go back to that page. Sorry, I have to go all the way back. Okay, here. So when I add model attribute, I give a name to it, message or text. So if I have to access this value, then I use the $sign and curly bracket, and inside that I'll put this name. So it automatically knows what value to get.